Here are the answers for the section 9-7 homework. Starting with number 1 on the oral. We're asked to solve this equation, but without using a calculator. So to do this, let's apply the theorems from this section. When we have a sum of logarithms, as long as the logs have the same base, and these are both base 10, we can rewrite as a log of a product. So 2 times 3 is 6. So the left side of the equation can be rewritten as log of 6. And then if that's equal to log of n, we can easily see what n is. N equals 6. For number 2, on the left side of the equation, there is a sum of logs, and the logs have the same base. So we can rewrite the left side as log base 3 of 5 times 6, which is 30. And if that's equal to log base 3 of n, then we can see that n equals 30. Number 3, on the left side of the equation, there's subtraction. So we can condense that into log base 7 of 15 divided by 3, which is a 5. And then from that, we can see that n has to equal 5. Number 4, on the right side of the equation, there's subtraction. So we can condense that to the log of 4 divided by 20. And then we can see that n equals 4 over 20. But that does reduce to 1/5. Number 5, on the right side of the equation, we have adding and then adding again. So the right side of the equation condenses to log 1/2 of 2 times 3 times 1, which is a 6. And then we can see that n equals 6. And finally, problem 6. On the right side, let's do some condensing. Log base square root of 2, and then the 3 plus 6 part right there, that changes into timesing. 3 times 6 is 18. The subtraction turns into division. 18 divided by 2 makes a 9. And so we can see that n equals 9. So the theorems used to condense expressions in this section are very helpful when you solve equations with logarithms. Now on the written assignment, we're asked to solve the equation. Let's do that same technique. Rewrite this as log of n times 5, which is 5n. And that's equal to 1. Now we want to solve this logarithm. Remember, if the base isn't shown, it's automatically a 10. So 10 to the first power is equal to 5n. Divide both sides by 5, and we get 2 is equal to n. Number 23, on the left side of the equals, let's condense this difference. So you write log base 5 one time, and then a difference of logarithms converts into division. So x cubed over x. That's x squared. Now let's solve this. 5 to the second power is equal to x squared. So what's x have to be? X has to equal 5. Number 25, on the left side, let's condense to a single logarithm. When it has a subtraction, it condenses into a division, n divided by n minus 1. And that's equal to log base 6 of 3. In the next step, we can say that n over n minus 1 is equal to 3. Then multiply the n minus 1 to the right side, getting 3n minus 3. Now subtract n, getting 0 is equal to 2n minus 3. Add the 3 to the other side, then divide by 2. So 3/2 is equal to n. Number 27, let's condense on the left side of the equation. Log base 7, and then when you have a sum of logs, it condenses into a product. So x plus 1 times x minus 5. We have 7 to the first power is equal to the x plus 1 times x minus 5. Let's do FOIL on that expression. X squared minus 4x minus 5. Then subtract 7 to get a 0 on the left. Now factor the expression. We can see that x is equal to 6 or negative 2. Number 29, let's condense on the left side by writing the log only one time. When this is a minus sign, the argument has division in it. We have the base 2 raised to the second power is equal to the 9t plus 5 over t squared minus 1. So this is 4 is equal to 9t plus 5 over t squared minus 1. Let's multiply the t squared minus 1 to the other side next to the 4. And because this is quadratic, highest degree 2, let's make standard form, getting 0 on the right. Now we'll solve the equation. T equals 9 plus or minus 81 minus 4 times the value of A times the value of C, all divided by 2 times the value of A. Let's simplify inside the radical. When I type that expression inside the radical in the calculator, it makes 225. And the square root of 225 is a 15. This will generate two answers. 9 plus 15 divided by 8 makes t equals 3. And then 9 minus 15 divided by 8 makes negative 3/4. For the review assignment, we're going to make inverses. To make the inverse of a relationship, you interchange the x and y. Then it's customary to solve that again for y. So to get y alone, we have to do the square root of both sides. Switching sides, we have y equals positive or negative square root of x. We're asked if this relationship is a function. For any positive number you put in for x, this is going to generate two different y values, one with the positive sign, one with the negative sign. So this is not a function. It violates the vertical line test. Now we're asked to graph the original function and our inverse. Let's do the original function in green. It's y equals x squared, so it's a parabola. Let's do our inverse in red. When x is 0, y is 0. When x is 1, y is positive 1 or negative 1. When x is 4, y is positive 2 or negative 2. It is this sideways parabola. Number 4, let's create the inverse of this. Interchange the x and the y. Then solve this for y. So first let's subtract 2 from both sides. Then divide by negative 1. Now do square root to get the letter y alone. This is not going to be a function. For example, when you use 1 for x, 2 minus 1 makes 1, the square root of 1 makes 1, but in front of that is a plus minus, meaning you would get positive 1 or negative 1 when you use 1 for x. Now we're asked to graph. Let's do the original in green. When x is 0, y is 2. And then we have a downwards opening parabola. We'll do our inverse in red ink. When x is 2, y turns out to be 0. When x is 1, y is positive 1 or negative 1. When x is negative 2, 2 minus negative 2 makes 4, and the square root of 4 makes 2, and we have plus or minus that. Here is a sideways opening parabola in red ink. Number 6, let's make the inverse by interchanging x and y. There's our inverse. This is a vertical line, so it's not a function. We'll do the original in green ink. It's the line y equals negative 1. And we'll do our inverse in red ink. It's the line x equals negative 1. Number 8, let's make the inverse. So you interchange the positions of the x and the y. Then resolve it for y. So times y to the other side, then divide by x on both sides. Is 1 over x a function? Yes, it is. Because for any number you plug in for x, you're only going to get one y value with it. Now we're asked to graph. Let's do this original one in green and make an xy table. When x is 0, you have 1 over 0, which is undefined. When x is 1, we have 1 over 1, which is 1. When x is 2, we have 1 over 2, which is a half. Let's do some negative x values. 1 over negative 1 is negative 1. Let's use x as negative 2. We have negative 1/2. And we'll graph those. We have some hyperbolas that fit in between the x and y axis. Let's switch to red ink for our inverse. Hey, that equation is identical to the first one. So we would draw the exact same hyperbolas. The red ones simply overlap the green ones. This is a special case where this function is its own inverse. Number 10, let's interchange the x and the y. Then to remove the square root, square both sides. Now subtract 36. And to remove squaring, do square root. This is not going to be a function, again because of the plus minus symbol in front of the square root. As you start to plug in numbers for x and evaluate the square root, whatever you get, you're going to get a positive and a negative version of it. Now we're asked to graph. Let's do this one in green ink. When x is 0, we have the square root of 36, which is 6. So 0, 6 is on the graph. What if x was a number such as 6? We would have 36 plus 6 squared, which is 72. We would have the square root of 72. How large is the square root of 72 on a calculator? It's 8.4. So 6, 8.4 is a dot on the graph. And if x was negative 6, we would get that same dot. So we have a shape like this. Let's switch to red ink for the other one. What if x was 6? 6 squared is 36. 36 minus 36 is 0. So this would all turn out to be 0. When x is 6, y is 0. And similarly, when x is negative 6, y is 0. What if x was any number between negative 6 and positive 6? Then when you square it, you would get a number less than 36. And then when you subtract 36 from a number less than 36, you would get a negative number in the radical, which is undefined. In our graph, there will be nothing in between those x values. But it would be okay for x to be larger than 6. Like, what if x was 7? Then we would have 7 squared, which is 49, take away 36, which makes a 13 in the radical. What's the square root of 13 on the calculator? It's 3.6. So when x is a 7, y is 3.6 or negative 3.6. Similarly, when x is negative 7, we would have those same two values. It looks like we're getting hyperbola branches like this.